integration method is, I'm not saying it's wrong. It's one way. This is more. So now come back to this here. And we are going to consider this red dot over here. Okay, the dot over here is our red dot. Okay. So we are going to do summation moment Z at point X is equal to what? 0. Right? So the 50 times 10 to the power 3 is what? Is doing a clockwise rotation. So minus 50 times 10 to the power 3 X. This is the force. Multiplied by the perpendicular distance, which is X over 2. Right? And then plus by M as a function of X. This is equal to what? 0. Sorry, both are going in the anti-clockwise direction. Both are what? Positive. So when that's the case, moment about X is equal to what? Is equal to minus 25 times 10 to the power 3 X squared. So because it's what? This is in what? Second order. Now we know why it's second order. So when we substitute X is equal to 0.8, M at 0.8 is equal to minus 25 times 10 to the power 3. Now multiplied by what? 0.8 squared. Okay. So this will be equal to 25 power 3 times 0.8 times 0.8 is equal to what? Minus 16 times 10 to the power 3 Newton. Are we clear? So that is why it's what? Second order. Okay, so again, we derive this by using the physics and the math combined. Okay. So we know over here, we're going to have a what? That phase. I think this is just a quick recap. Right. This position, wrong color. This position is very important. Can someone tell me why this position is very important? Is it different color or is it me? It's you, Eugene. This position is very important. Why is this position very important? Anyone? Maximum what? Huh? Bending moment. Okay. When shear force is equal to 0, bending moment is at its what? Maximum. Are we clear? It can be at its minimum. We don't know. We need to what? We need to check. So the next thing we have to determine, okay, we have to determine this location. Okay, I mean not this location, but this position over here. Okay. So this position over there, I'm going to label this from here to here. I'm going to label this distance from here to here is X, right? And then from here to here is what? It is 3.2 minus 0.8, 2.4 minus X. Okay. So we are going to determine our position of X. Okay. So I'm going to call this alpha circle. So alpha circle is what we're trying to achieve over here. We are trying to determine the X position where V is equal to 0. Okay, Y when V is equal to 0. There is a possibility that M max will what? Will occur. Why do I put there is a possibility? Why is it a possibility? Because if you look at this graph, can you all tell me where M max or where V is equal to 0? At this position, where X is equal to what? 0.8 also. It also crosses the what? The 0 line, right? So is that the maximum? Yeah, it's possible. That's why we have to check. We're clear. That's why we have to check. So we know the next thing that comes out, we are going to determine the X distance. So we will have 80 or 80 times 10 or times 10 to the power 3 over X. Okay, so there's, and then this will be equal to 40, or you can don't equal to, I think you can equal to 40 times 10 to the power 3 over 2.4 minus X. Okay. So when you do the cross multiply, so you get 2 multiplied by 2.4 minus X. This thing will be equal to X. Okay. So 4.8 minus by 2x, this thing is equal to x. X is equal to 4.8 divided by 3. So 4.8 divided by 3 is equal to 1.6. So this distance over here is equal to what? 1.6 plus by what? So it's at 2.4 meters. Okay. So now we know down here at 2.4 meters, there's a possibility that our what? Our bending moment will be at its what? Maximum. Okay. So we are going to find that this value, we're going to find our M max down here. So M max is equal to half times base. So base is equal to what? Base is equal to 3.2 minus 0.8, 2.4. Times by 80 times 10 to the power 3. Minus by 16 times 10 to the power 3. Okay. So 80 power 3 times by 2.4 times by 0.5 minus 16 power 3 is a half times by 2.4 times by 80 power 3 minus by, it's not 2.4, usually it's 1.6 because it's the area. Can you change this to 1.6, please? So 80 power 3 times 1.6 times by 0.5. So it's equal to 48. Okay. So this 48, is it smiling face or sad face? So is it doing this? Or is it doing this? Yes. Huh? Sad face, right? Why? Why? You're right. Because you're sad today. This is because when the shear force when the magnitude is positive, right? The gradient is what? Is positive. Yes or no? So when the magnitude over here, when the shear force magnitude is positive, the gradient is what? Positive. So positive gradient belongs to this curve over here. Yes or no? Okay, so this is wrong. Are we clear? Okay. So the last bit, we know that at 32, right? The bending moment is what? The bending moment is equal to 40 times 10 to the power 3 multiplied by 0.8. Okay, so 40 times 10 to the power 3 times by 0.8 is equal to 32 times 10 to the power 3. So we have 32 down here. So this thing will do a set phase coming down. Okay, and then now why is coming down this way is because negative what? Magnitude correspond to negative what? Gradient, yes or no? And then finally, when there is no load or distributed load, the ending part is a what? Is a straight line. Right. I'm going to get rid of this so it's not so confusing. Now, from here, we are going to select a few points. Yes. Yeah, you can do that, but you just complete the curve, the second order polynomial coefficient is the same. Okay. Right. So from here, the next thing we have to find is we have to select location. Okay. So what points are you going to use? Okay. Definitely x is equal to 0. Forget it. There's no stress. 4.0, forget it. Nothing to look. At 0.8, what is happening? Can someone tell me? At 0.8, you have minus 16 times 10 to the power 3, right? And then you have a shear of what? Of 80. Okay. And then when x is equal to 2.4, so let me highlight what are the points I'm talking about. So you have this point to consider, right? You have this point to consider, and you have this point to consider. So here x is equal to 0.8, x is equal to 2.4, and x is equal to 3.2 to what? To consider now. Because where failure will occur, you can pick two, but now we're going to pick. So we're going to select 3 location. The location. Oh, it's given by God. No, 3 location. These 3 location when x is equal to 0.8. Why when x is equal to 0.8, you have what? You have Vmax, right? And then when x is equal to 2.4, you have what? Nmax. Now, why did we pick x is equal to 3.2? If you look at x is equal to 3.2, it somehow has the best combination of both. Yes or no? Right? It has V equal to minus 40 kilonewton, and here's M, which is equal to what? M is equal to 32 times 10 to the power 3. Right? So is the best of what? Okay, so you have to check 3 position. Yes. No, yield. Depend on ductile or brittle. Yes. Yeah, don't know. So we have to check. Okay, as engineers, we have to check, and we're going to use what? 3D mole circle what? To check. Are we clear? Okay, I'll see you in an hour's time.